Hello and welcome to another video. In this video we're going to be working on missing number. And in the problem you're given an array nums containing n distinct numbers in the range 0 to n, and you want to return the only number in the range that is missing. So in this first example, the range 0 to n here is 0 to 3, so the number is missing is 2. Here the range is 0 to 2, so we're missing 2. Here the range is 0 to 10 or something, or 9. And we're missing 8. So there's a few ways to do this problem. Some are kind of obvious and some are not. So basically, we're given some array of length n, and we need to get all numbers from 0 to n. So one really obvious way is just sort. So let's say we have like this. We can just sort our array. We can get like 0, 1, something, 3. And we just look for what's missing, right? So we need every number from 0 to 3. We just go through our number and make sure, is it the next one, and so on. So we look for a 0, we have a 0, then we look for a 1, needs to be the next one, then the next number needs to be 2, it's not 2, so we just return 2. And if this was 0, 1, 2, then we would look through this whole thing and we would just return 3. So that's pretty easy to sort. The other basic way of doing it is a set. So you can just say like, I'll just store every number from 0 to n in a set. Right, so let's say our set will have 0, 1, 2, 3. Then I'll go through my array, and every time I encounter a number, I'll just remove it from my set because these numbers are unique. So I encounter the 3, remove it, encounter the 0, remove it, encounter the 1, remove it. And then whatever's left will be your missing number. So those are two easy ways. Now we'll talk about two a little bit more complicated ways. And so one of the ways is with bit manipulation. And the way to use bit manipulation that you have to know here is an XOR operation. And you have to know that XOR, when you XOR a bunch of numbers, so if you XOR A, B, A XOR, so this is the symbol for XOR, A XOR B, XOR C, it works kind of like a sum where the order of the numbers doesn't matter. So this is the same as this. Because all XOR is really doing is just counting up the number of ones and in a specific bit. And if it's odd, then the XOR will be 1, and if it's even, it'll be 0. So let me show you that quickly. So let's say we have some numbers like this. We XOR these. So basically, we just go through one bit. We just check if it's even, this will be 0. So here, it's even, so this will be 0, even, 0, even, 0. Because every time you have a 1 and a 1, it makes a 0. So this XOR together will be 0. And if there was something odd here, like let's say it was like this, then it would be 1 here. So the order doesn't matter. You're just counting up the number of bits, kind of like a sum. So you know that. Now also, another important formula for XOR that you need to know is X, XOR X equals 0. Because like I said, for XOR, you're just counting up the number of bits. And if it's even, you'll get 0. If it's odd, you'll get 1. Well, if it's X, XOR X, all the bits will be the same for both numbers, right? So like something like this, XORed with itself. For every single bit, you just count up is the number of ones, odd or even. So because a number is XORed with itself, for every single bit, it will always be even because every number will just have 2 ones where it has a 1 or 2 zeros where it has a 0. And so we can combine these two things together. So now that we know that the order doesn't matter, so we know that like if we do A, XOR B, XOR C, XOR A, this will be equivalent to B XOR C. Because A XOR A is 0 and the order doesn't matter. Right? You can kind of imagine this as a sum, like let's say A is like 5, and then when you XOR with another A, you're kind of like adding -5. Like if you do this and then you add some other numbers at any other point, this will always be 0. So that's kind of the same thing here. So if you have a bunch of numbers that you XOR, anytime you encounter the same number twice, the XOR there will be 0. And so we can use that to make this thing here. So like, let's go through this example 3. So in this example 3, the numbers we're looking for, the range is 0 to 9, right? N equals 9. So we're looking for 0 to 9. So we could say like 0 XOR 1, XOR 2, XOR 3, XOR 4, and then all the way down to, so 5, 6, 7, 8, 9. These are all the numbers we're looking for. So we can just loop from 0 to n, get all those numbers, get a result here. So all these numbers XOR together. And then we can also XOR them with every single number that's actually present in the array. And so I'm going to kind of show these where they are, but we're going to XOR. So there's a 9 here. So there's 2 9s. there's a 6, 2 6s, 4, 2 4s, 2, 3, 5, 7, 0, and 1. So when you XOR all of these, and then you XOR all of these on the bottom, basically every number that occurs twice will go to 0. So this will go to 0, this will go to 0, this will go to 0, 0, 0, 0, 0, 0, 0. Then you'll just be stuck with a number you have missing. So that's like a tricky way of doing it. You basically XOR every number in the range of 0 to n, because those are the numbers you're looking for. Then you take that and you XOR all the numbers in the array. And then because the order of the numbers you XOR doesn't matter, every number will have a duplicate. And then there will be one number left. And that one number left will be your result, and every duplicate will go to 0. So that's one way you could do it. You could also do this with a sum and a minus if you wanted to. So you can just say, like, let me add up 0 to 9, right? Like if I don't use these XORs again, well, I could do this with a sum, and it'll work as well. So you could say, instead of XORing all these, let me just add all of these. So add up every number in the range of 0 to n. Add. Then subtract all of these. And then these will cancel, 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 cancel. So that's another way to do it. Instead of XORing, you can add every number in your range and then subtract every number in your array. And then the difference will be the number that's missing, because the number in the range has one number that's not in our array. So that's another way you can do it. Now the last, so this is kind of like the one we'll code, but there's a little trick here that's useful for harder problems. It's not necessarily useful for this one, but it's useful for harder problems to know. So if we wanted to get the sum of this like arithmetic sequence, there's a way to do this, and there's a formula that they show on LeetCode a lot, but it's you don't really see how it's derived, and it's pretty easy to derive. So the sum of an arithmetic sequence where every single number is like the previous number plus a constant number, right? So this is 1 is 0 plus 1, 2 is 0 plus 2 is 1 plus 1, 3 is 2 plus 1, and so on, right? Every single number in here differs by 1. This is called an arithmetic sequence. So the sum of an arithmetic sequence is the first number plus the last number over the total amount of numbers. So here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times the length of this thing. And this makes perfect sense if you think about it, because basically what you're doing for an arithmetic sequence that increases by the same amount, you're basically saying, let me get the average, and let me get the average and multiply that by the number of elements in my sequence. And that will give you the sum. And that makes perfect sense, right? You just get the average because this is constantly increasing. You get the average, and then you just multiply it by the number of elements in the sequence. So you can actually get the sum here in O of 1. So the sum here in this example would be, let's also make some values for this to make it a little bit easier to find. So let's call this, let's call n like the length of the sequence, I guess. Right, so the length of the sequence, or let's actually call n, let's say n is 9. Yeah, so let's call n 9. So basically the sum of all these numbers, and we don't need to really include the 0, right? Because the 0 doesn't really matter, so this doesn't add anything to the sum. So the sum is really just this. So for the sum of this will be n, which will be the last number, plus the first number, but the first number was 0, remember? So the first number was 0. And the length of the sequence is 10, so it's over 10, right? So this is the average multiplied by the length of the sequence, which is n plus 1. So that's how you get this, like they show this a lot, where it's, I think I did something wrong here. Oh yeah, I did do something wrong. So I screwed that up a little bit. I'm not sure if I did the equation wrong, but so basically to get the average, you have to do the last number plus the first number over 2. I'm not sure if I did it over 10. You have to get over 2, right? That's the average. And this works for an arithmetic sequence, right? So if you think about it, the average here would be 4.5, and that's because there's 5 numbers that are less than 4.5 and 5 numbers that are greater than 4.5. So 4.5 is right in the middle here. So that would be the average. So the average is n over 2, and then the length of the sequence is n plus 1. So that's how you can come up with this formula that the sum of an arithmetic sequence that goes like this is n times n plus 1 over 2. And you see this formula in like a bunch of LeetCode problems where they basically give it to you, but this is how you derive it. So we can use this to actually get it. So we can get the sum of our sequence just by our n is whatever number we're provided. Our n plus 1 is that number plus 1 over 2. So we can get our sum, and that's going to be this sum here. And then we can calculate the sum of our array, which is just the sum of every element. So then our number we're missing is just going to be this total sum, which is this equation here, minus this equation here, or the sum of the array. And obviously, you can just add these up in a loop instead of doing this equation, but this will be useful for things like, let's say instead of having this, you have to do this in O of 1. There are problems like that where you have an arithmetic sequence you have to do in O of 1. Or if your arithmetic sequence is like 10 to the 9th or something. I just wanted to show this because this is useful to know how to derive this equation. So this is the thing we're going to code up in our final solution. So we're going to say our total expected or something. So let's actually get a value for n, right? So if n is just length of nums, because all of the numbers are going to be 0 to some number, missing a number, right? Like going back here, the length of nums is right over here. So it's 2, 4, 6, 8, 9. So n is the length of nums, and then we want every number from 0 to n. So our expected will be n. Let's go back and look at our equation right here, n times n plus 1. So times n plus 1 over 2. And this will always be a whole number because either n or n plus 1 will always be even here. So it's our expected. Our actual is just the sum of the numbers. And then our missing number is basically just the difference here. So return expected minus actual. And there we go. So that's kind of like the fast way of doing it. You recognize this is an arithmetic sequence. This is the formula for an arithmetic sequence. And then we get the sum of our actual sequence, and there's one number missing in our actual sequence, so we can just subtract that. You could also do this in a loop if this doesn't make sense. You can just add up every number from 0 to n. So if you add up every number from 0 to n, it'll give you this exact same thing. And yeah, so this is going to be O of n, where n is like the length of the array, and space will be 0 or 1. And yeah, so this works. The bitwise one works as well. I'm not going to code that up, but it's pretty straightforward as well. Just take every single number from 0 to 9, XOR them together, then XOR with every single number in the array. The missing number will be what's there. I guess we can actually do that really quickly. So we can just say like result equals 0 for I in range 0 to n plus 1. Right, we want 0 to 9. We don't need 0, I guess. We could do it like this. Result XOR I, and then for I, or for num in nums, result XOR that num, and then you'll have one number missing, so you just return. So it'll be basically like this for the bit when pretty fast. We need this variable still. So that's how, whoops, let's see here, see what I did wrong. Oh, right, you need to do XOR equal to maintain it. There we go. So either one of these is good, whatever you prefer, but these are kind of like the tricky ways. You can also like manipulate the actual input, but that's not super recommended. So just pick one of these. I think these are both useful and both used for harder problems. So they're both good things to know, that the XOR of a number with itself is 0, and XOR of numbers, the order doesn't matter, and this like how to calculate this part here by yourself. And yeah, it's going to be all for this one. So if you did like this video, please like it and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.